All right, folks, let's get into the alkynes. Or as I say, the triple threats. They're ruled by the acetylene godfather, okay? And this family values their triple bonds as a symbol of their dominance. And of course, that dominance has to do with that reactivity, okay? They're unsaturated hydrocarbons. So that means they definitely do not have the maximum amount of hydrogen bonds, right? And they have to have at least one carbon-carbon triple bond, meaning they are going to be sp hybridized. So of course, the examples when it comes to these alkynes, their overall uses are going to be just like everything else. They're going to be a part of raw materials, for chemicals, welding, rubber, all kinds of things, right, folks? And the naming, which is so cool, we're talking about layering, right? It's just like alkene. So you're going to have your, of course, you're going to have your prefix, your root, and your suffix. For the root, you will need a location, just like you saw for the alkene. For the suffix, instead of ending in E, it's now going to end in Y-N-E, I. Remember, all of this entire process and learning all this is just to organize these compounds. We haven't even gotten to the details about reactions and how to do that because you're going to see that in organic chemistry, okay? Also, just like the alkenes, you must put a location on the triple bond. So here we have the butene, because we have a triple bond here. That means instead of starting the counting for the carbons at 1, 2, 3, 4, we're going to start here at 1, 2, 3, and 4. Same thing with hexyne. Hex means there's going to be 6 carbons. So we want to make sure that we're going from 1, 2, 3 here or 1, 2, 3 here. That means you can basically start at the lowest number on either side. It doesn't matter which side you start with. I can put 1, 2, 3, 4, 5, 6 this way, or I can do 1, 2, 3, 4, 5, 6 that way. Either way, the hexyne is going to be on carbon number 3. The butene here is going to be on carbon number 1. Okay, so you got to have your location of triple bond. You got to make sure the carbon chain is numbered from the end closest to that triple bond, and everything's going to end in -ine. All right, so let's get to it. So we know that our suffix is going to end in -ine, and we know our root has to have a location attached. We want to start numbering closest to that triple bond. So when I'm looking at this, I'm like, I know I have to start with carbon number 1 over here. So let's start numbering. 1, 2, 3, 4, 5. That's 5 carbons. 1, 2, 3, 4, 5, 6. That's 6 carbons. 1, 2, 3, 4, 5, 6. That's also 6 carbons. So it doesn't matter which parent chain I choose over on this side, it's going to be 6 carbons. 6 carbons means that I have hex, right? So I know I'm going to be dealing with hex. And our suffix is going to be -ine. So it's going to be hexyne. Now we have to put a location of our triple bond. This is going to be carbon 1, 2, 3, 4, 5, 6. So the location of the start of it is going to be 2-hexyne. Now, of course, after we get our parent chain, we figure out our substituents. We have one that is going to be 2 carbons, and of course, one that's going to be 1 carbon. So that means we have an ethyl group here, and we have a methyl group. We put them in alphabetical order. Ethyl comes before methyl. They're both in the same carbon, though. So we're going to put 4-ethyl, -4-methyl, -2-hexyne. That's that one. Now let's get into this one. Again, the goal is to start numbering where the triple bond is. So I'm going to start numbering here. 1, 2, 3, 4. That's only 4 carbons. 1, 2, 3, 4, 5. So this would actually be my parent chain. 1, 2, 3, 4, 5. 5 is going to be pent. It ends in -ine because we're a triple bond. The location of the triple bond is going to start with 1, so that's 1-pentine. And then now we just focus on substituting. We have a methyl group here. Okay, so that methyl group is on carbon 3. So it's going to be 3-methyl-1-pentine. Okay, folks, let's get into our final hydrocarbon, the aromatic compounds, or the benzene bosses, okay? They're going to be guided by the big benzene himself. And this family's aromatic rings emit an aura of mystique that helps them with resonance, and of course, in creating so much more diversity with organic compounds. Their functions are numerous, right? So we have solvents, raw materials for dyes, perfumes, all kinds of stuff. So we want to make sure that we're just keeping a couple of those, a little bit of those functions in mind, okay? Now, I know that you might not have seen it, but all of these should have a flashcard moment. So if you don't see that, just please make sure you're stopping yourself for those videos. Oh, I do see it right here. Everything should have that flashcard moment. Make sure you're stopping yourself and consolidating that as well. Now, aromatic hydrocarbons contain a benzene ring. That means this is what a benzene ring looks like, okay? They have alternating carbon single bonds and carbon double bonds. And not only do they alternate, they also provide resonance. So this double bond can be moved here, this one can be moved here, and this one can be moved here. Now, because this is flush with double bonds, this entire thing is called a benzene. All right? That's what it's going to be called, a benzene. You also can see it written this way. has a circle in it just to signify that it has 3 double bonds within that ring. Okay, folks? So with this group, you must have a benzene ring involved. Now, another tricky part about this group is that they actually tend to have a lot of common names. So sometimes you won't see the benzene ending. Like you see benzaldehyde here, benzoic acid. You won't actually see the benzene ending, but for our course, you will see the benzene ending. Of course, when you go up higher, you can get more detail. Okay, folks? Now, to name the aromatic compounds are going to be just like the alkenes, okay? Or the alkynes, for example. But the only difference is when you have your prefix, your root, and your suffix, the root and suffix are going to combine to form a brand new thing called benzene. So that benzene is going to signify this ring. So instead of having to come up and be like, oh, ene or ine or anything like that, no, the entire root and suffix are going to combine. We'll have benzene. The prefixes are going to act just like they've been in. Let's get into a couple of them. All right, so we know we're going to have the same components, prefix, root, and suffix. And we know our root and suffix are going to form benzene. So when I see a benzene ring, I'm automatically going to end this with benzene. When you're on the exam, you will be ending it with benzene. You will not be focused on the common names. So both of these right off the bat are going to end in benzene because that root and suffix are going to combine. Now we need to focus on prefixes. For this one here, we know benzene is always going to mean 6 carbons, but now we got to focus on all of our substituents, which helps us contain and figure out our prefixes. Now, as you can see, there's halogens here. So we don't have to just see haloalkanes. Now here's halogens on the aromatic compounds, and the naming is still the same. You want to make sure that you are starting with, because you're all the same halogens, it's pretty much easy. So you want to make sure that you're starting with the lowest number as you possibly can. So I'll just take the first chlorine and just make sure I name it as 1, 2, 3, 4, 5, and 6. Okay? You could have started 1, 2, 3 here. You could have started 1, 2, 3, and then 4 and had a 1, 3, 4 chloro. But again, the question becomes, can I get the lowest number? Those aren't the lowest numbers. So the way I just numbered it will give me the lowest number, 1, 2, and 4 versus 1, 3, and 4. Okay? So I have a 1 dash 2 or comma 2, comma 4 dash trichlorobenzene. So you see, I'm just adding layers of those prefixes. Now I'm thinking of the halogens. I'm like, okay, it has to have chloro. How many of them do I have? 3, right? What are their locations? 1, 2, and 4. So then I'll write this again, 1, 2, and 4, trichlorobenzene. So it's all about making sure that you're numbering things properly, especially when you have the same substituents. If this was like chlorine, bromine, etc., we would have to take into consideration alphabetical. When they're same, we don't. We just take into location of it. So we have 2 bromines here. If I started this as 1, 2, 3, 4, 5, 6, that means I'll have a 1 bromine and a 4 bromine. And it doesn't matter which way I number it, it's going to be the same. So I have a 1, 4 dibromobenzene. Okay? Di because I have 2 bromos here. So as you can see, folks, it's all about layering information. I mean, you can use your flashcards and write these examples down, make sure you're laying information, have all the little details you can to help you get through this process. Now, some of you may be wondering, how do all these compounds come to be? And guess what the answer is? Good old chemical reactions, all right? And there are specific organic chemical reactions that, of course, you will be able to learn more about when you get into organic chemistry course. Like substitution, where you're actually substituting the carbon bond. So here's OH attached, now it's chlorine. Addition, you have a ring here that has a double bond, now it has bromine attached to it. Elimination, you have an OH here, now there is no OH, and there's a double bond. Rearrangement, rearranging actual single and double bonds as well. And then we'll actually have to know one single type of reactions, which are going to be redox, which we'll see a little bit later on. And that'll just be a quick way for you to do some of those examples too. All right, folks, now let's get into each of the 8 families and see some of their properties and reactions. We have gotten through the hydrocarbon. Woo woo!